Hi, and welcome to the video on using the solubility rules chart. This video is designed to help you with your homework. We didn't have an opportunity in class to practice using the solubility rules chart, and it may seem a bit confusing at first. So the key takeaway here, and as with any chart, is make sure you read what the chart says. Read the headers and the section headers, just so you have an idea. So this is the chart from your textbook that I've linked for your homework. This is the solubility guidelines for common ionic compounds in water. So this is not all of them. This is just the common ionic compounds, meaning it has a metal and a non-metal part. This chart is divided into a soluble side. So these are soluble ionic compounds, and compounds containing these polyatomic ions are soluble with these exceptions. The other half of the chart contains insoluble ionic compounds. So it means that compounds containing these, notice these are all anions, are insoluble, meaning they do not dissolve in water, with these exceptions. So how could we use this chart? You may have a problem like this where it says mix lead nitrate and potassium iodide, and the question is there a reaction? Let's first understand what they mean by is there a reaction. For these exchange precipitation reactions, there's a reaction when a precipitate forms, meaning one of your products is insoluble in water. So how do we go about solving a problem like this? First thing we need to do is we need to set up some sort of chemical reaction equation, just so we can identify what our products are from these reactants. Notice that the reactants we're given the names and not the chemical equations. So let's start by writing the chemical formulas there. Lead nitrate and potassium iodide. We know that these are the things that we're combining in our reaction. Now for exchange reaction, the metals switch with the nonmetals. So here the first metal is lead, and that's going to switch up with the nonmetal in the second one. And I'm saying metals, but loosely what I mean is the cation. So the cations and anions switch, because we know, for example, ammonium NH4, which is written here, that could potentially be one of your cations, and it's not a metal. We also know, as you saw in the textbook, that the protons in an acid compound also is a cation, and that would switch as well. But that's a little side note. So let's go ahead and switch things around. So I'm going to switch the lead here with the iodine and the potassium with the nitrate. And we get these two products, lead iodide and potassium nitrate. Great. So the question is, which one of these is a solid, if any? Remember, if we do not have a solid, if we do not have an insoluble compound, there's no reaction. Now, I'm a bit anal, so I actually normally start on the reactant side just to make sure that my reactants are soluble and aqueous, because I'm always afraid they're going to trick me and put one in that's not soluble, in which case that also wouldn't be a reaction. So you need both of your reactants to be aqueous. So I'm going to start with the lead nitrate. This will also give us a chance to practice using the chart. The question is it soluble or not, right? So this chart has only the anion, so I'm focusing on the anion of each of my compounds. Starting with the nitrate here, I look to find it in the chart, and here it is. It's in the soluble ionic compounds, meaning that all nitrates are soluble with what exceptions? There are none. So that means that the lead nitrate is also soluble, so it's going to be in the aqueous phase. Okay, let's do the same thing for the next compound. I look for the anion because this chart only has anions. And so I see there's the iodide here. Okay, cool. So I look for the iodine, and there it is. So again, this is in the soluble side, so I know that all iodides are soluble with which exceptions? Well, take a look. There's silver. This is a dimercury. It's a special polyatomic ion. And lead +2. Guess what? My cation is potassium. It's not a part of these exceptions, so I know that this must be soluble as well. All right, now we're going to do the product, which is the most important part. You don't really need to do the reactant unless you're like me and afraid someone's going to try and trick you there. So lead iodide is the first product I see. Again, this chart focuses on anion, so what's the anion here? Iodide. Great. We're going to look in the chart to see if there where iodine is in the soluble ionic compound. So that means that all iodides are soluble, with which exceptions? I look over to see if I can find an exception for my lead, and I do. So what does that tell me? Is lead iodide soluble or insoluble? Yep, it's insoluble because it's one of my exceptions for the soluble ionic compounds. So I'm going to give it a phase indicator of S, meaning that it's a solid. So that means, whoop-de-doo, we have a reaction because this is my precipitate. All right, and just to finish this off, we know that we do have a reaction now because we have two soluble or aqueous phase compounds forming at least one solid. So we know there's a reaction, but we'll finish it off by checking to see if potassium nitrate is soluble or not. So again, look at the anions for this chart. The anion is nitrate, that's in the soluble side. So I know that it's not, there's no exception, so that potassium nitrate is soluble. Okay, so just to recap what we've done here, we wrote out the reactants and the products, and then we look to see if one of our products is a solid to see if there's a reaction or not. One final note, we only use the soluble ionic compound size of this chart, but note that the insoluble, you sort of do the opposite in thinking, because for compounds like, let's say we had potassium sulfide, I would be thinking that all sulfides are insoluble, not soluble in this case. And if I saw an exception, I would say that, oh, that means that it's soluble. So, so for example, if this was potassium sulfide, I would say, okay, so sulfides are insoluble with the exception of, alkali metal cations. Guess what? Potassium is a group 1 metal. That's an alkali metal. So I know that, hey, guess what? Potassium is soluble, not insoluble. So just be careful about where you are on the chart. Final note here, this is not the only solubility guidelines for aqueous solutions. You also have that in your reference pages. If you Google, they'll look different. So the important things with any chart, make sure you read it, make sure you understand what it's telling you. This chart, which you have access to the reference pages, has more anions. It also lists the cations as well. So it's a little bit different in what's listed there, but it's sort of set up the same way: common soluble compounds with exception and insolubles with exceptions. All right, I hope you found this video helpful and have a quality day.